Let's talk about the multiplication of two vectors. There are two different ways you can do this. The first one we'll talk about is a method that gives a scalar quantity. The other one we talk about later will give us a vector quantity. This goes by several different names. Sometimes it's called the scalar product or the vector scalar product to emphasize that you get a scalar. Probably most commonly, it's called the dot product, and we'll see that that's because the symbol that you use to indicate you're performing this operation is a dot. And it's also a form of what a mathematician would call an inner product. That's very important in understanding linear algebra. I will just use the term dot product most of the time. Okay, here's the definition. The dot product of two vectors A and B, you see that you have A, B, and a dot that's centered vertically, it's just read A dot B, is defined, that's what the three-line equal sign means, as the magnitude of A times the magnitude of B times the cosine of the angle between them. So if we draw a sketch, A and B, there's what theta is. Notice that A cosine theta is the component of A in the direction of B, the parallel component. So sometimes you'll see this written as the parallel component of A times the magnitude of B, or also the parallel component of B times the magnitude of A. The dot product gives you a magnitude of one vector times the component of the other vector that's parallel to the vector. If we look at our definition, we see pretty quickly that the two magnitudes on the right side are never negative. They can be zero if we have a zero vector, but they're not negative. And so if we have a non-zero vector, they've in fact got to be positive. And so we can say that the dot product is itself positive, is greater than zero, if the angle is less than 90 degrees, because angles between 0 and 90 degrees have cosines that are positive. The dot product is equal to 0 if the two vectors are at right angles to each other, and the dot product is negative if the angle between them is larger than 90 and up to 180. The way we define this angle when we say the angle between two vectors, it can't be bigger than 180. If you try and spread two vectors apart until they're farther apart than 180 degrees, say 200 degrees, well then you can just use 160, and you should in this case. Finally, let's think about how to deal with this if we have components for our vectors, or if we have our vectors in terms of components. So here are A and B written out in unit vector form. Term on the right side, you have A with three terms added, then it's a multiplication of this sort times another term with three added, and so when you multiply that out, you're going to get a bunch of different terms. Some of those terms are going to have one unit vector times itself, and any unit vector dotted with itself is equal to 1. You have the magnitude of the first one, it's a unit vector, so that's 1. You have the magnitude of the second one, it's the same vector, that's also 1. And you have the cosine of the angle between a vector and itself, that angle is 0, that cosine is 1. Okay, so any term that results that has the two dot products of the same unit vectors, we can replace them by 1. The other terms will have the dot product of one unit vector with a different unit vector, since those are all perpendicular to each other. Those are all 0. And when we put all this together, here's a very easy way to remember and to write out the dot product in terms of the components. Multiply the x components together, multiply the y components together, multiply the z components together, and add those three terms.